All right, number 2. We have a 150-pound prisoner walking this plank on a ship. The plank weighs 110 pounds and is 12 feet long. What we're trying to find here is how far out the guy can walk measured from here, which, by the way, is the axis. If this plank tips, where is it going to tip from? Right there. That's the point where, when it's on the verge of tipping, that's where it's going to happen. That's our axis. So first thing I'm going to do is I'm going to do a free body diagram for the plank. So let's shrink this down, and we're just going to focus on the plank. So that's our picture of what's happening. So let's just put a plank in here. So this represents the plank right there. And then the axis is not in the center. It's actually a little bit off center. Right there, that point right there is the axis. Now there's 2 torques acting on the plank. We have the weight of the plank itself, which we're told is 110 pounds. And then we have the guy. The guy is over here on the plank, and he has a weight of 150 pounds. And then there has to be a normal force holding everything up, right? When the plank is balanced on that point right here, there's a normal force, but it's not going to factor into the problem because it's directly on the axis. Forces on the axis cause no torque because the lever arm is 0. Okay, so what makes this problem somewhat, it's not even a hard one, but if there is a challenging part to this, the challenging part is with the distances. So let me erase the problem. Basically what we're solving for is how far out the guy can go. So I'm going to erase this and then label our distances. So from the center of the plank, over to the end of the plank is how far? 6 feet, because we were told the whole plank is 12, so half of 12 is 6. Now, we're also told in the problem, we're told that 5 feet of the plank sticks out over the cliff, right? So this distance from there to there is 5 feet. So what must this distance be? 1 foot, right? That's important, right? Now, why is that important? Because notice, that's the perpendicular distance from axis to force for the 110-pound Newton force, or the weight of the plank. That's 1 foot right there. Perpendicular, so it's not difficult in that regard. Okay, now what's this other distance going to be? From the axis over to the guy, what do we call that? X. That's what we're looking for. So now it's really pretty simple. So let's do clockwise, counterclockwise. This guy is pushing which way? Clockwise. This guy is pushing counterclockwise. So you sum the torques. We have 2 torques. Starting with the positive one, so we'll say clockwise is plus, counterclockwise is minus. So we go 150 pounds times x, right? And those guys are perpendicular, right? They're perpendicular. Minus 110 pounds times 1. Oh, you don't need to multiply by 9.8. Pounds is a force. Yo, Allie.
Oh, that's what I was going to ask. How come you're not multiplying it?
Oh, because, well, look, actually, it doesn't matter what you're, see, kilograms is not a force. So in the previous problems where we had mass, I multiplied that by 9.8 just so it was a force. But just realize pounds is a force. Pounds, that's an acceptable unit for force. It's not metric, but it's not going to matter what our unit is, because I'll show you in a minute. Pounds is going to cancel. This pounds and this pounds, it's going to cancel out. Okay, so look. So we take this is going to equal 0. The torques are going to cancel. So when you solve this, you're basically going to have 150 pounds times x equals 110 pounds times 1 foot. The pounds cancel, and x is going to be 110 times 1 foot over 150, and that comes out as 0.73 feet. The answer comes out in units of feet. So that's the answer. The guy, without tipping the plank, he can walk out 0.73 feet. If he goes out 0.74, what's going to happen? The plank will tip, and he's going to fall off the board.